Okay, so we learned about z-score, we learned about normal distribution, and we learned how to calculate z-score. In this video, we put it all back together. At the end of this video, you should have a better understanding of how to apply z-score into a probability problem to answer the question. And this is an example. It says a Ford Escort gets an average of 28 miles per gallon with a standard deviation of 1.6 miles per gallon. If an Escort is selected at random, what is the probability that it will get more than 31 miles per gallon? Assume that miles per gallon is normally distributed. That means we have the right to put it on a normal curve. Now let's use the facts that they gave us. They told us the average being mean, so I know my mean, x bar or mu. And I know that my standard deviation is 1.6. So this is sigma or s. And again, mu looks like this. Make it look a little better than I did at first. Our mean or average is 28. And our standard deviation is 1.6. So I'm going to add 1.6 to 28. That should give you 29.6. You add it again, you get 3 standard deviations to the right. So after that, it's 31.2 and then 32.8. So I've added over 3 standard deviations to the right. Going to the left, that's 1, 2, and 3 standard deviations. 1 standard deviation to the left is 26.4. And then it is 24.8. And then another standard deviation is 23.2. So that's our graph with the mean and standard deviations shown. Then it says if a Ford Escort is selected at random, what's the probability that it would get more than 31 miles to the gallon? So basically, we're given an x value, and x is 31. In order to answer this, we need a z-score, which is x, take away x bar over sigma. So basically means the number they gave us, 31, take away the mean divided by the standard deviation. So that should be 31, take away, the mean was 28 over 1.6. If you plug into your calculator, it's ought to give you a z-score of 1.875. And we can round it up to 1.88 because 1.875 is now in our z-score table. So 1.88. So we have a z-score. So we converted 31, which is probably around right here. We converted that to a z-score. That z-score is 1.88. The reason why we convert it to a z-score, if I can figure out the area that's beneath this curve, I can begin thinking about how I can answer this question. Area beneath the curve is to the left of 31, or to the left of that z-score. 31 isn't on our z-score table, but that is 1.88 is. So I'll go to my z-score table and find 1.88. So here's 1.8. And then here's the other 8. And I want to see what they meet. So this is going to be right here. 0.96995. So this area is 0.96995. So note the area underneath that curve, there's a 96% chance, basically about a 97% chance, that I would choose a Ford Escort that's below 31 miles to the gallon. It's a very good chance I could choose a Ford Escort that drives below 31 miles to the gallon. And the question says, what is the probability that we get more than 31 miles to the gallon? So instead of getting that side, I need to use what I know to figure out this half of the curve and make it red. So I want to figure out all those Ford Escorts, Ford Escorts to get 31.2 or 32 miles to the gallon, maybe even 33 miles to the gallon. So I want to know how many of those are. If I got 96.997 that doesn't get that much, I will take that from 100. If you subtract that from 100, you should get about 3.005%. So that's the percent of people who have a Ford Escort that can go more than 31 miles per gallon. So we like to answer our question in statistics as a sentence. Our job is to tell someone else the data and explain the data to them. So we would answer this question as about 3.005% of Ford Escorts get more than 31 miles to the gallon. So I put it in a sentence. So about 3% of Ford Escorts drive over 31 miles to the gallon. And that's how we can apply Z-score into a word problem. I hope that makes sense. Good luck.